Hey everybody, today we are going to be talking about lesson 5-7, equivalent algebraic expressions. This will be using the different properties of mathematics. So we'll be talking about those. If you have your green math folder, those are also in one of the pockets of that folder. So this would be really helpful for you on this assignment when identifying the properties. All right, so we are on page 315 in your workbook. And we'll go ahead and get started. All right, so the first thing we're going to do is use properties to identify equivalent expressions. So when we've talked about equivalent before, equivalent means equal, right? So we're finding things that are equal. And these will actually be expressions that are equal. They have the same value. Algebraic expressions are equivalent when they have the same value no matter what value is substituted for the variables. You can write an equivalent expression by applying the properties of operations to an expression. So the first property we have here is the commutative property. And it says it doesn't matter really what order you multiply or add, the sum or the product will always be the same. So 7 plus 9 is equal to 9 plus 7. 8 times 4 is the same as 4 times 8. We can even use that with variables. A plus B equals B plus A. A times B equals B times A. We also have the associative property, and this is really close to the commutative property. The only difference is we're dealing with 3 numbers here. It doesn't matter how and what order you add or multiply 3 numbers, the sum or the product will always be the same. So 3 plus 4 plus 7 is the same as if we did the 3 plus 4 first versus the 4 plus 7. The 6 times 2, cat's destroying things here. We can do 6 times 2 first, or I can do the 7 times 6 first. Either way, it's the same answer. Same thing with our variables. So if you don't have your green folder, this is probably pretty handy to hang on to. So you might want to rip out page 315 from your workbook and keep that nearby, especially for your tests that will be coming up. We also have the distributive property, which is what we worked on yesterday. That's when you distribute what's outside in the parentheses into both terms inside the parentheses. We can do that with both addition and subtraction. And the identity property says that a sum of an addend and 0 is the addend, right? If we add 0 to any number, it's always just going to be that number. We also have the identity property of multiplication, which means any number times 1 is just that number. So those are rules that we've known about since you started math. Now we're just giving it a name. So this is the identity property. So when we take a look at a problem like this right here, 4 times 2x plus 3 plus 5 and 4x plus 3 plus 5, we know that they are equivalent. What we can do is simplify the expressions, and then we can figure out what property they are using. So first things first, we can use the distributive property to solve here, okay? So if we did that, 4 times 2x would be 8x, 4 times 3 is 12, and then we still have a 5. And then we use the associative property to add them together. We can then do, if we were to solve this problem here, this is showing the associative property. It doesn't matter what order you do it in, it would still be the associative property. So now we know that these two expressions are not equivalent because we didn't end up with the same answer when we've simplified them. So let's take a look at 2 more. So we have 8 plus 3n plus 2, or 3 times n plus 1 plus 7. So the first thing we would want to do is simplify this. We can combine like terms. The 8 plus 2 can go first, right? Because we can combine those two numbers. Then we would have 3n plus 10. Let's try this one now. Distributing the 3 in. 3 times n is 3n. 3 times 1 is 3, and then we still have a 7. Then we use the associative property to add our 3 plus 7 to get 10. So then we can compare 3n plus 10, 3n plus 10. These two expressions are equivalent. So let's take a look at example 1 on page 317. We are going to determine whether or not these two expressions are equivalent. So the first thing we need to do is simplify. So we use the distributive property. 3 times x is 3x. 3 times 7 is 21 plus 2. Then we use the associative property to add together our constants. These are our like terms, right? 21 plus 2. We can't add in the x because we don't know what x is. So you don't want to combine x unless you see another x. So when you do that, 21 plus 2, you get 23. So the answer here would be 3x plus 23. Let's take a look at our second expression, distributing the 3 into the x and 6. So then you would end up with 5 plus 3x plus 18. We can then rearrange to combine like terms, 18 plus 5, which is 23. So our expression is 3x plus 23. Are these two expressions equivalent? Yes, they are. We came up with the same answer, so we know they are equivalent. All right, let's take a look at the next problem. This is your check. It says use the properties to determine whether or not 1/2 a plus 1/2 b is equal to 1/2 a plus b. Well, we're going to use the distributive property here. If we have 1/2 a plus b, remember we distribute that 1/2 into both expressions, or I'm sorry, both terms. So then you'd end up with 1/2 a plus 1/2 b. So is this equal to 1/2 a plus 1/2 b, which was our first expression? Yes, they are equivalent. So we would find that that is an equivalent expression. All right, so let's move along now to page 318. We're going to be talking about using substitution to identify equivalent expressions. So step 1, we're going to evaluate the expressions for the same value of the variable. Now, y is equal to 0 here. So we would say y plus y is 0 plus 0 plus 0. So the answer here would be 0. 3y is the same as 3 times 0, which is 0. So remember, this is the identity property, okay? Because anything times 0, or anything added to 0 is just the answer, right? So the answer would just be 0. So we can use 0 here for this problem. This obviously is another rule that we know, that anything times 0 is 0. So now let's try it using 5. Y plus y plus y. 5 plus 5 plus 5 is 15. 3y is the same as 3 times 5, which is 15. So would y plus y equal 3y? Yes, they are equal, because when we use substitution, we're able to prove through a variety of different numbers, right, that they are equivalent. Now, let's take a look at this one. We're going to determine whether 5 times x plus 4 and 5x plus 4 are equivalent using substitution. So let's use x as 0. Okay, so we're going to use x here. We're going to plop that in. 5 times 0 is 0. 5 times 4 is 20. So 0 plus 20 is just 20. Let's try this one here. 5 times 0 is 0. Plus 4 would just be 0 plus 4. So the answer here would be 4. So would these be equivalent? Using substitution, we came up with two different answers. So we would know that 5 times x plus 4 and 5x plus 4 are not equal. So let's try this with example 2 on page 319. Using substitution, we're going to determine whether or not 2x plus x and 4x are equivalent. So if we were to plug in a 0 here, 2 times 0 plus 0 plus 0 plus 0, 4 times 0, they're both 0. Let's try it with x equaling 1. 2 times 1 is 2, plus 1 is 4. 4 times 1 is 4. Okay, so those work. How about if we tried a 2? Well, look at that. We got 8 for both answers. So we know that these are equivalent because they all have the same value when the values are substituted for the variable. So let's go ahead and try that with this problem here. We have 3x plus 4 and x plus 2 times x plus 1 plus x. So what if x equals 0? 3 times x, so 3 times 0 would be 0 plus 4 would equal 4. Let's do the same thing over here. 0 plus 2 times 0, which would be 0 plus 2 times 1, which is 2 plus 0, is equal to 2. So are these equivalent when we look at the two numbers using substitution? No, these are not equivalent expressions. Now, moving on to example 3, we can determine equivalency once again using substitution. We can even do it when we have fractions. So if we have these two expressions, they're very lengthy, I know. Simply go ahead and replace 0 every time you see an x. 1 half 0 is 0, 0 squared is 0, plus 1 half would just be 1 half. If we do the same thing for over here, right, we still get 1 half. But what if we try another number? So it's important to not just try one number when using substitution. What if we used 1 here? 1 half times 1 is 1 half, plus 1 squared is still 1, plus a half would be 2. 1 half times 1 is a half. 1 squared is 1 times 3 is 3, plus 1 half, right? So now we're up to 4, minus 1 would be 3. Oh, so because we have two different values, the expressions are not equivalent, okay? Because they don't have the same value when x equals 1 and x equals 2. So let's try that here. Let's try this with y equaling 1. So if we did that here, we would have 1 plus 2 times 1 plus 3. We'd have 1 plus 1 plus 2 times 1 plus 1. Okay, so if we were to solve this, 2 times 1 is 2, plus 1 is 3, plus 3 is 6. 2 times 1 is 1, plus 2 times 1 is 2, plus 2 times 1 is 2, so this is 4, 5, 6. This equals 6. What if we tried it with a 2? Replacing the y's with 2. 2 plus 2 times 2 plus 3. Okay, 2 times 2 is 4, plus 2 is 6, plus 3 is 9. Do the same thing over here. 1 plus 2 plus 2 times 2 plus 1. Now distributing in, 2 times 2 is 4, plus 2 times 1 is 2, so that's 6, 7, 8, 9. So because we got the same answers when we tried both 1 and 2, these two expressions are equivalent. All right, moving on. So let's talk about combining like terms. An expression is in simplest form if it has no like terms and no parentheses. You can use the structure of an algebraic expression to combine like terms and write it in simplest form. So when we have an expression with only constants, like 5 and 2, right? We can just easily combine those to find the answer is 7. The same thing works if we only have x's, right? 3x and 5x. We can add those together. 3x plus 5x is 8x. Now, if we were to use algebra tiles, which we don't really use much in 6th grade, it makes a lot more sense because you can always combine the greens, right? Greens with greens, yellows with yellows. So think of numbers like 4, okay, as being their own thing, right? You can't combine them anything different than what they are right here. So this is 4. But you can combine all the greens. 2x plus 3x would be 5x. So then the expression we would have here would be 5x plus 4 because we have 5 x's and 4 yellow tiles. Now, when we take a look at a model like this, right, we can combine all the like tiles. If we had x plus 5x plus x, we can simply combine all of those x's into one row and find out that the expression would be 7x. All right, so combining like terms. So let's go ahead and circle like terms that are x's and underline those that are constants. So anything circled we can put together. We can combine 2x plus 4x. 2x plus 4x is 6x. 5 minus 2, because there's a minus sign, we have to subtract 2, would be 3. So the expression combined with like terms would be 6x plus 3. So let's go ahead and try this here. Circle those with x's, underline those with constants. So once again, we can combine the x's. 2x plus 1x is 3x. 5, now be careful, there's a subtraction sign, so we're going to do 5 minus 1 would be 4. So then our answer here would be 3x plus 4 would be our expression. Now, what if we have squares? Ooh, that's something totally different. So now we might need to make a box around those involving squares, circle those involving just an x, and underline the constants. So we can then sort those terms into the correct boxes. Okay, so we can then combine those. 5x squared plus 1 more x squared would be a 6x squared. 2x is all by itself. And then we have a 2 and a 6, which would be 8. So the simplified expression would be 6x squared plus 2x plus 8. I really like to use symbols to help organize my thoughts, and that will help you as well. So let's go ahead and try this with our check here. Put a box around anything with an exponent. Circle any just normal x's. Oops. We can't do that with this one here. Okay, so we have to do something different. Because these are cubed and this one's squared, we have to do something different. I'm going to circle this one because it's on its own. And then we can underline what's left over. So now we can combine this. 2 plus 1 is 3x cubed plus x squared plus 0.5 plus 1.5 is 2. And that would be our simplified expression. All right, so let's talk about properties here. So this is where that page 315 and 316 will come in handy. So you want to probably keep that close by, okay? So when you simplify an expression, you can apply properties to combine like terms and to write equivalent expressions. So when we were to do this one, okay, we are then just simply combining like terms to find the correct expression. So this one right here, right, we're going to first use the distributive property to get 12x plus 3, and we have 2x squared plus x. Now let's rearrange it. Box around anything with an exponent, circle any x's, underline the constant. So 2x squared will come first, and we have 12x plus x, which would be 13x, and then we would just have our 3 left over. All right, so we're going to skip that last one. All right, moving on to our reply problem here. DeWitt wants to buy some vintage comic books at a local shop and have them shipped to his cousin. The price of a comic book is based on its condition. The table shows the total cost of X numbers of comic books for each condition. He buys 2 that are in excellent condition, 2 that are in good condition, and 2 that are in fair condition. With the shipping cost for the comic books is $5. What expression represents the total cost of buying and shipping comic books? So what we would do here is we would go back. 2 in excellent condition. So we're going to have 2 times 18x. Okay, then we would move on. 2 that are in good condition plus 2 times 9.75x, and 2 that are in fair condition plus 2 times 4.5x. Then we need to add on $5. So now what we would do is use the distributive property, right? Multiply this, okay? Multiply the 2's into each of these expressions. And then combine all your like terms. You can add all of these together once you figure that out, and then add in your $5, or keep your $5 separate because that is a constant. So when you have completed this, please email me your answer as always, because this is your apply question. This is your bit of a challenge. And let me know if you do have any questions with it. All right, as always, please let me know if you have any questions on anything in the assignment. Please make sure to complete it in McGraw-Hill. And I hope you have a great day.